So, hello everybody. Welcome to the next UNICAT Live. It's already live number 11. And today the topic again is electrical systems on expedition vehicles. We had the same topic last time, but there were quite a lot of questions coming up, which I would like to answer today. Electrical systems is a big part of a expedition vehicle, and these days almost everything in the vehicle has a cable, has something to do with electricity, and therefore I think it's good to make another live about this one. I'm also receiving questions to my email address, but I would like to ask everybody who has such a question to send it to through the channel, through YouTube or Facebook, so that everybody can finally see the answer. Most of the questions I think are interesting for more than that one specific person, even so it's a personal question. Please be so kind, use our channels to post the question, and then I will answer them during one of the lives. In general, the idea of the lives is to share information, to bring some basic information to all the people who are just interested generally, who are planning to build or to buy an expedition vehicle, just to get some sensibility about all the necessary details. And the idea is to share our knowledge and to help not making mistakes. And therefore all the questions, please send them through the channels. We also get more and more questions about, okay, where can I buy this part? And where did you get this lock from, or this post for a wash basin and things like that. Generally, we are not selling hardware. We are not selling the stuff we are manufacturing for the UNICAT vehicles. That's just not our business. A lot of stuff is manufactured in-house, or at least modified in-house, to meet the standards we want the UNICAT vehicles to be at. But please understand that we don't want to sell these parts to improve other vehicles from other manufacturers. I think everybody should go their own way, and so please don't send requests on can you sell me these locks, or can you make this part for me or that part for me. We are manufacturing complete vehicles. That's our business. We are happy to help in the expedition scene a little bit with knowledge, but no parts. Of course, no drawings, no real detailed instructions how to do this or how to do that. I mean, hopefully everybody understands that, because that's what we learned the hard way through decades, where all our energy is in, and we are that's UNICAT, and UNICAT should stay somehow UNICAT. Okay. Sorry. Yeah, let's start with the questions which were left over from last time. And if you have new questions, of course, you're welcome to post new questions, and we will use the time to answer the questions. Okay, and some questions are quite long, so they cannot be completely shown here. So I have a list of these questions. You might excuse that I'm reading that question from my list. So the first question is, generally, how much solar and amp hours would you recommend for a completely electrically powered rig, oven, hob, and hot water with diesel as your backup? Well, even if the rig is completely electrically powered, which I think is the future, except for heating, there is a big range of how much the consumption can be. You can have one air conditioner or two air conditioners. You can be a person who starts the air conditioner when it's really getting hot, or you might be a person who has the air conditioner running all the time. That makes a huge difference. Therefore, it's impossible to give a clear answer. You need to make your own calculation, yeah? Or you need to get help from somebody to make that calculation. If we have a order, or if we have somebody asking for a UNICAT vehicle, at a certain point, we definitely speak to him, and we always try to understand the people, how they live, how they travel, because only then we can lay out the vehicle as good as possible, including the layout of the electrical system. So yeah, air conditioner is a good example. If you run the air conditioner maybe occasionally, then you don't have to really calculate it in your battery capacity if you have a diesel generator as a backup, because then you can say, okay, in the rare occasions I run the air conditioner, I just start my generator. And it wouldn't make sense to provide battery power for something that's only rarely switched on and needed. While if you turn on your air conditioners pretty much all the time, then you will need quite a lot of battery capacity, and that's a range from 1 to 20. And therefore, you need to make a calculation based on the consumption of the items you're running, the time you expect to run it per day, and then you make the addition, and you know how much electricity, how much energy you will use per day. And then if it turns out to be like 4 kilowatt hours, and you want to be independent for 3 days, then it's 4 kilowatt hours times 3. It's 12 kilowatt hours available electrical power. That doesn't mean that this number is the voltage times the amp hours, because you never get 100% out of your batteries. In last live, I said that if you have AGM batteries, you can expect to have 50% of usable energy, and with lithium batteries, you can expect 80%. You need to make the calculation. No, I think I said it 3 or 4 times. You see, I think it's important. But if you want a figure, yeah, then I would say even for a small 4x4 expedition vehicle with not so much electrical equipment like oven and hob and air conditioner and so on, 5 kilowatt hours of available energy from the batteries, I think, is somehow the minimum. And the maximum we typically put in larger vehicles, I mean, it's in 6x6 vehicles with 7-meter body, which are typically very well equipped. We put like 18 to 24 kilowatt hours of available battery energy. And that's everything above 12 kilowatt hours typically is based on lithium batteries, because if you want to provide that with AGM batteries, then you get a lot of weight and a lot of volume. So once you go above 12 kilowatt hours, it's lithium. Yeah? So the range is 5 kilowatt to 24 kilowatt. Diesel as a backup. I don't know if you mean diesel as a backup for heating, because you can make hot water with electricity if you have plenty, but you should not try to heat the body with electricity. That's just too power consuming. So that should be done with a diesel heater. And also it should be possible to heat the water with a diesel heater, which is providing hot water. And if you combine that with the engine cooling system, then you can use the waste heater of the engine to heat the body and the hot water as well. And that's the system we use, and that works fine. Okay. Okay. And then the other question was how much solar? Well, you can never have enough solar. There will be rare occasions where a vehicle with running on full where the solar system will provide enough energy to run all the systems. Today, a solar system can run an air conditioner, it can run a hob, it can run everything, but still, sooner or later, your battery level will go down. Therefore, the more solar you can put on the roof, the better it is. While I would not do a lot of effort to maximize the output of the solar system. I mean, cleaning the solar panels from time to time, it's a good idea. That makes a difference. But lifting up the solar panels towards the sun, following the sun, that's something I actually wouldn't do. I would rather try to really maximize the solar panels on the roof. Okay, next question. Okay, Thomas, can you talk about sizing inverters to the loads, please? Well, that's pretty straightforward. So if you have an air conditioner, which has a power requirement of 1,500 watts, and you have a hob that requires 3,000 watts, and you intend to run them at the same time, then you need an inverter that constantly can provide 4,500 watts of power. And again, you have to decide for yourself what you will have on board, and you will have to make the decision if you want to be able to run everything at the same time. So now you have, okay, let's say you have an oven, you have a hob, you have an air conditioner, you have a hair dryer, which requires a lot of power, and some other stuff. So it might end up being 10 kilowatt. You would need maximum if you run everything at the same time. But do you want to install 10 kilowatts of inverter? I would say no. I think you should be ready to not run everything at the same time. So if you have a peak of 10, I would say you should have two inverters of 3 kilowatts, or one of 5, but 2 of 3 is better because you have a backup and you have a redundancy. And but that should be the permanent output. It does at a little bit raised temperature level. So the good companies like Victron, for example, which is our supplier, they give you exact information how much the nominal output is, but also how much the unit can provide at which temperature level. And I mean, inverting means you have a loss, and that becomes heat. So first of all, you have to ventilate your technical compartment. Still, the temperature will be a little bit higher than the ambient temperature. So you have to calculate that on a higher temperature level, so that you then still have enough inverter power. The peak the inverter can provide, I think, is not that interesting, because that's only for 30 seconds anyway. And therefore, I mean, what can you do in 30 seconds? So look at the nominal output, look at the temperatures, and then spec the inverter according to this, and make sure you buy a real good product. There are cheap products, but they never do what they advertise. And therefore, I think buying a well-known brand with a good reputation is important. There are other good brands beside Victron, but I'm not in advertising here, not too much at least. Okay, next question. Is there a special name for these universal all voltage chargers? I was expecting to fit something like an isolation transformer, but this sounds a lot easier. Yes, actually, it's a lot easier. But there is no particular name. We call it international charger, but that's our own term because that's the purpose we install it for. But if you look at the catalogs or the home pages of the manufacturers, you just have to check the specs, and you will see if it says input 90 to 260 volt AC, then you're fine. Then it's what we would call an international charger. Okay. Next question. How do you manage to charge batteries from shore power in 115, 230, 60, and 550 cycles environment? Well, that's very easy. We talked about that last time. What we do, we design the vehicle inside either, or we lay it out in 230, 50 cycles, or 115, 60 cycles. Depends on where the home base is. But let's say it's a 230, 60 cycle vehicle. Means all the appliances, the air conditioner, the hob, the oven, maybe the fridge, freezer, the receptacles for the kitchen appliances, for the hair dryer. Everything then is made for 230 50 cycles. Now, as long as you are in a country where the shore power is 230 and 50 cycles, it's no problem at all. Actually, the inverter charger unit is checking what's coming in, and if it's clear and if it's clean and if it's in the range you want to have inside the vehicle, it's just directly connecting through. So you have no losses through the inverter. If the what's provided by shore power is different, I mean, either the voltage is too low or the frequency is not right, then the inverter will not work or will not connect through, and will just simply work as inverter, taking the energy from the battery, providing 230 volt, 50 cycles AC inside the vehicle for everything that's connected. So everything works inside the vehicle. Okay, now the question is, how do I recharge the batteries at the same time? And that's what you do with these international chargers, because the international chargers take any voltage you get from any shore source, and they make 24 volt DC to charge the batteries, or they make 25.6 volt or whatever is required for the battery system to charge the batteries. And while the shore power provides energy, the international chargers use that energy to charge the batteries, and at the same time the inverter takes energy from the battery to provide the 230 50 cycles inside. That's the system, and that yeah, works fine. We have good experience with that, and it's easy. So there is no okay, now we have to do this or that. You just plug in and you're done. Okay. So the next question is, let me see, let me repeat it from Michael. I mean, do you use 12 or 24 volt secondary alternators? Well, let me postpone this the answer to that question a little bit, because I know from my list that we are talking about alternators as well. So, and the other question was, do you add isolation transformers to cope with 100 volts and 220 volt? Well, no, we don't, because we use these international chargers. Now, we used transformers in the old days before these quite smart and actually very, very practical international chargers existed. But since they exist, we have taken out all the transformers from every vehicle which came back, and we never installed a transformer in a new vehicle. The point is that transformers are very heavy, and they are huge. So that's not really funny. And they have a big problem. They don't convert the frequency. So if you come in with 60 cycles, 110, and you transform it to 220, it's still 60 cycles. It can't change the frequency. Other problem is that if you go in with 110 and you have only very little load on it, then the voltage at the out will maybe be 260, 270 volt. And when you have more load on it, the voltage will go down. It will go down to 250, 240, 230, 220, 210, and even lower, depending on the size and the quality of the transformer. But the ratio of transformation is not always exactly the same. Like you would say, I want 1 to 2, but it's not exactly like that. And that's a problem if you have only a little load, but you put 270 volts on some charger device or some sensitive electronics like a music system, it might blow up. And that's another reason not to use transformers. Okay, so next question. Do you use something like Balmer alternator with off-board regulator to regulate charge, or do you tend to use DC to DC chargers? Okay, we use both. As I said last time, it's a good idea to have a second alternator mounted at the engine, because you have completely independent electrical systems for the chassis and the body. Now, the alternator that's installed on the engine should only work for the chassis, and it should be untouched. It should just stay original. While to charge the body batteries, you should have a second alternator, independent alternator. And there are also different requirements to that alternator. First of all, the typical alternators are made of pretty cheap magnetic material. So the efficiency is about only 30 to 40%. At least that's what it was. Now the manufacturers are going to better products with more efficiency, but still the efficiency is quite bad. That means if you only have 30% or 30% efficiency, if you provide 1,000 watts of electrical power, you produce 2,000 watts of heat. And that means that if the alternator has to work hard all the time to charge a huge battery pack, it will most likely overheat and die. That doesn't happen with a normal setup, because the chassis battery is, compared to the body battery, relatively small, and you do not really completely discharge it every time and have to recharge it full. So the work the alternator has to do for the chassis is not so hard, and therefore the bad material doesn't matter so much, and all the heat that's produced will not hurt the will not kill the alternator. Also, the normal regulators on the alternators are only set to 14 volt, 14.0 volt on a 12 volt system, and 28.0 volt on a 24 volt system. But if you charge a 24 volt battery set only with 28.0 volt, you will never get it fuller than 70% at average temperature. If the temperature is higher, it's not even 70%. Only if it's really getting cold, then the battery will be charged like 80, 85, 90%. But just to keep the system safe and simple, the manufacturer said, okay, let's stop it at 28 volt. It's sufficient power to start the engine. So why should we ask for trouble? Okay. Now, if you charge your body batteries with that same alternator, first of all, it has to work much harder, much longer, and it might overheat. Secondly, you would also only be able to charge your big battery pack, which you paid for a lot of money, only to 70%. Now, if you use such a alternator to charge lithium batteries, which require even a higher voltage, you maybe get to 50% of charge only. And that would make the investment in lithium batteries totally useless. So to properly charge body batteries with an alternator, you have to have an external regulator which you can adjust to the appropriate voltage. And if this is a good unit, then it will also measure the temperature of the battery, because the required voltage depends on the temperature of the battery to protect it. And it will also measure the temperature of the alternator, because you will still use it a lot. But something should protect that alternator from overheating. And that can also be that external regulator, because if it measures that the alternator is getting too hot, it will reduce the voltage that goes into the alternator, and therefore the amps and voltage that comes out is also reduced. So external regulator is a very good thing to have. Now, when we transfer power from one battery set to another, we use DC to DC converters, because that's a very controllable way to do it. And also, it's not limited to any source that electric power is coming from. Well, if you want to charge your generator batteries, in brackets, if you have a diesel generator, this diesel generator should have its own electrical system as well, including its own starter battery. Now, so if you want to charge that starter battery, which should always be full, so you can start your generator when needed, when you want to charge that battery from another source, the DC-DC converter is the best option, because then you charge it straight from the body battery, and it doesn't matter where the body battery gets its power from. Could be from shore, could be from solar, could be from the auxiliary alternator. Okay, next question. Oh, okay, let me answer that other question. Do we use 12 or 24 volt alternators? Well, it depends. If you have a 12 volt system, then of course you use a 12 volt alternator. And if you have a 24 volt electrical system, you use a 24 volt system. Some vehicles even have a 12 volt system on the chassis and a 24 volt system on the body, or the other way around. The voltage of the alternator just has to fit with the voltage of the electrical system. Okay, if you have a separate chassis battery system, and I'm too slow following the banner, so I wait for it to come up again. If you have separated chassis battery system and body battery system, how do you deal with the battery management system shutting off the charge of the body batteries, as normally this would fry the alternator? Okay. As said, you should have separate chassis batteries and body batteries anyway. So that's a good question. You only disconnect the batteries from charge if you have an emergency case with lithium batteries, because if lithium batteries get overcharged, they are dead. If you overcharge a HEM battery or lead acid battery, it's getting warm, it starts making gas, stuff like that, but it's not instantly dead. But a lithium battery will be dead. That's why the battery management system, in worst case, will disconnect the lithium battery from all sources of charge. Now, you disconnect it from shore power by shutting off the charger. You disconnect it from solar by shutting off the solar regulator. You also have to disconnect it from the alternator, but that's a bit more tricky. But the way we do it is, first of all, when you disconnect the batteries from the generator, no, from the alternator, it's still connected to the users. I mean, to the consumption part. And the dangerous thing is that the diodes in the alternator can break if the voltage goes too high. But the voltage does not generally go up and up and up. It's peaks of high voltage, but that's enough to kill the diodes. So what we use is a device to protect the alternator from these over voltage peaks. So that's a general precaution, and it solves the problem. And of course, we disconnect we don't disconnect the external regulator, but we set the injected voltage to 0 so that it's not pushed to produce higher amps and higher voltage. So we set the external regulator to 0, and we have a over voltage protection on the alternators. Okay, next question. Do you use 230 volt generators attached to the chassis engine? No, we don't. The alternators produce some AC, but the AC, the frequency depends on the RPM of the engine. So to make clear 230 50 cycles AC coming from the alternator, you have quite a relatively big unit in between, and that should be in a dry place. And the question is, why should we install all that when we can get straight the right DC voltage to charge the batteries? And we don't need the 230 directly from the alternator. That's the job of the inverters. So why should we do it in different ways? That's not a clear system, and that's why we don't use this type of alternators. Okay, can you jumpstart the engine with a lithium battery by simply connecting them with a jumpstart wire? Principally, yes. I mean, you should not start a 12 volt car with a 24 volt battery system from the body. But if your truck is 24 volt and your body is 25.6 volt lithium, then it works. So you should make sure, but that's then typically the case, that the voltage of the lithium batteries is not at the absolute peak, which only happens if the batteries are full, and you're still trying to charge. Yeah? Then it can be above 29 volt, and we know that that the regulators for 24 volt systems are set to 28 volt. So as long as you stay below 28 volt, your systems in the truck will be able to handle that. But if you have your lithium batteries and they are not getting charged, the voltage will not be above 28 volt, and you connect both battery sets. And what we do is that we have a battery main switch. This type of switch, which can handle a lot of amps, a lot of current. And with this, we can just directly connect the two battery sets. After the protective stuff of the lithium battery system. So you don't have to use cables and go to the battery poles and stuff like that. You just turn the key and you have connected both systems, and then amps current will flow from the full batteries to the empty batteries. If you have to jumpstart your vehicle this way, I would actually anyway wait a couple of minutes and allow the chassis batteries to recharge a little bit from the body batteries, so that the amps which are flowing when you start are not super high. If you do that with a cable, if you connect with a cable and not knowing your lithium battery system, I just have to point out that if you connect this directly, let's say you have a block of lithium batteries, 24 volt, you put the clamps there and you go to the other batteries. That's so far is okay, but if you discharge this lithium battery pack during that procedure below the minimum voltage which is necessary for the lithium batteries, this battery pack will be dead. So you have to be very careful, and especially when you jumpstart a truck, you have a lot of current going on, and the voltage will drop dramatically. And if that voltage drops below the voltage of the minimum voltage of the lithium batteries, they will die. So be careful with that. Okay, next question. Okay. Sorry. Beep Beep Africa is asking, Thomas, you said the vehicle and habitation or body electrical systems are completely independent. Do they share a chassis ground? Practically, yes. But we use a chassis, we connect the ground of our battery system to the chassis. But the truck manufacturers don't necessarily use the chassis as ground. So whether the two electrical systems are connected properly through the frame, that's a question that I can't answer for the different chassis manufacturers. So they might not use the chassis for ground purpose. So Thomas, great overview of electrical management for an expedition vehicle. Thank you. Considering the similar requirements for sailing yards. Okay, I have to to go in my list for sailing yachts. What's your view on the latest developments in solar panel technology being used by some reef yachts? Well, what they do, and what also other people do, is they apply solar panels on all kinds of surfaces. They put it on flexible stuff. They put it directly on walls, on fiberglass, everywhere, just to make use of all the surfaces which are exposed to sunlight, to create more solar power on a boat or on a vehicle. Principally, that's a great development, and we are looking forward to see that being introduced in the market in a wider scale. The more solar you have, the better it is. Very clearly. The one problem is that the efficiency of solar panels, which are applied to a solid surface directly, and other than normal solar panels, which are ventilated because there's some clearance between the roof and the solar panel, the efficiency will not be as good, because the higher the cell temperature is, the less efficient a solar cell is. So if you go to minus 40 degrees, your solar cells work best. And if you have it solidly on a surface, it might get up to 60, 70 degrees Celsius, and that's reducing the efficiency a little bit. But still, there is some output, and so it absolutely makes sense to look in that technology, and we use it occasionally if we want to put solar panels on the very top of a roof hatch, for example, or in other places where you just can't put a normal solar panel. It's a good idea. It's a great thing, and we hope that more products will become available. And then also the prices will go down. They are a bit expensive at this point. Okay, Thomas, thank you for making Monday my favorite day. What is your opinion on bus systems like Mastervolt CNET compared to classical switches? Bus systems are easier to install. They are great if they work. And they are quite reliable. I mean, in many houses, the stuff is used on. They use them on big yards and so on and so forth. But if they don't work, you are left alone with an electronic box, which you probably can't fix. You can replace it. Hopefully, your default mode will turn on all lights, but you want to have all your lights on all the time. So I personally don't like electronics where it's not really necessary. I mean, an inverter and a battery charger these days, they need to have electronics, because there is so much really smart stuff inside which really helps, and so we accept that. But what we do is we have at least 2 inverters, we have 2 chargers to have redundancy. So if something goes wrong, we still have one left over, without trying to fix an electronic system. I don't see why in a vehicle that would really be necessary. For the lights and for appliances to control that through electronics. I mean, it's not a huge house. Yeah, the distance to the next light switch can be maximum like 9 or 10 meters. Yeah, so why would I want to use my iPad to turn on the light if the switch is just next to me? My personal view and my view to reliability of systems. If it's just a switch, if it's wire, everybody can fix it, and that's important. Okay, next question. One topic that did not come up in the possibility to use electric cars, charging stations to charge your battery bank. Is it possible at all? We don't have such a system, but it definitely is possible. Yeah? I mean, every car charging station is a car charger. Yeah? It's high voltage current that goes into the car, and even high amps. I mean, a lot of power goes in there quickly. It definitely can be used. Maybe there is even something on the market, a charger that would do that. Yeah, I don't know it. We didn't install it. Does it make sense? Well, how often are you somewhere where you have a powerful charging station? It's mainly on a highway or in a town. The parking places are often relatively small. If you block 5 places with your truck, maybe you make 4 other people unhappy. It's an interesting idea, but principally it's possible, of course. Yeah. Okay, next question. I have never seen a wood stove in a UNICAT vehicle. Apart from its atmosphere, are they more safe to provide heat in sunless times and areas than battery and generator? Okay. We have installed wood stoves for the atmosphere and as a backup. And if a backup works completely with different sources and in a different way, it's the best way to have a backup. Yeah. I mean, we are not heating with electricity. We are heating with diesel fuel. So we have a Webasto water heater. It needs some electricity to run the pump and the controls, but it burns diesel to create the heat. Because these heaters, they need like 9 kilowatt, or they produce 9 kilowatt of heat. So imagine you would want to create that from electricity. Your batteries would be empty in no time. Still, it's a nice thing to have. I mean, the problem is that you need quite a lot of space, because you have to provide very good insulation between the stove and the walls. You need clearance, you need distance, and you need a good exhaust system so you don't get exhaust gas into the vehicle. So it should be completely sealed. The air, the fresh air should definitely come from outside. yeah, okay, and then you have to collect wood, or some other burning material to run that stove. And from all I know from staying in huts in Canada and stuff like that, I know that if the oven is relatively small, you have to add wood from time to time. So you get up at night a few times if you want to keep your vehicle warm. For the atmosphere, it's really great. We are going to install a cooktop, an oven, which has a stove, an oven, and which even creates or makes hot water. But if you go this way, it's getting quite complicated, because once the wood is burning, you are creating heat, and you can't stop it from creating more heat within a very short time. Like you could stop a diesel heater, or you could shut off an electrical heating system. So this is something you really have to think about how you do that. For example, you need, if you run hot water through it to make hot water, then you have to have an emergency cooling system, almost like, not as sophisticated, but principally like in a nuclear plant, where once the fire is on, the fire is on. So be careful if you intend to do that, and make sure it's a closed system, so you're not taking the air from inside the vehicle. It's a small room. If you get exhaust into it, you will have very quickly a toxic environment. So be careful with that. Okay. Similar related question for next time: if electrical appliance needs to be replaced, example washer, dryer, or fridge, is the door opening big enough to get it through? Yeah, yes, it is. Yes, definitely. It would be a big mistake if you couldn't get your appliances in and out. That would be really a disaster. Doesn't need to be the door, but could be a roof hatch as well. But there must be one opening that's big enough for everything. Yeah, because according to Murphy's law, if you can't get anything out, this will be the first thing that breaks. That's for sure. And also we do not build the vehicles from inside to outside. So we do not start like with a floor panel and then we put the washer dryer and then we make the furniture around. No, it's the other way around. We build the box, the house. And once that's built, we install the wiring and the tubing and all that. And only after that, we install the furniture. And once the furniture is installed, we can install the appliances. So we bring them in through that opening anyway, where if it has to be replaced, it will come out again. Okay. So I think we are at 7 o'clock. There is another question. We are drifting a little bit away from electricity. So let me answer this question here, which is a long question, and I will read it from my screen here and answer that question for today. Okay, I've been following UNICAT and Thomas Ritter for about 18 years now. Okay, thank you. Okay, there are some very nice words about, Michael is saying about UNICAT, and I will not repeat them here. Okay, he's driving Unimogs for his timber frame construction business. And using Unimogs for your platform vehicles. Okay, so one of the questions is more or less, are we still, why are we not using Unimogs anymore? Are we only using MAN trucks as platforms these days? And should he go for a MAN truck rather than using the Unimog he has? Okay, well, we are using less and less Unimogs and more MAN trucks because the vehicles we are building are getting bigger and bigger, more comfortable, and there are quite a lot of family vehicles where there are requirements for more space, for more beds, for more storage, and it's difficult to put all that on a Unimog chassis. And the Unimog chassis has a certain size. It's highly off-road capable, no doubt, but it has only a certain wheelbase. There are Unimogs out there with 3.25 meter wheelbase, which is a typical military wheelbase they used in the armies. There was a 3.7 meter wheelbase. There is a 3.85 meter wheelbase, and they did some vehicles with even 4.5 meter wheelbase. But the normal longest wheelbase which is available is 3.85 meter. Now you have the short engine hood in front, so the available space for a body on that longer wheelbase is about only 4.5 meters, maybe 4.9 meters if you don't put too much weight in the back. If you go for a longer body on a Unimog, you will take away so much from the off-road capability by putting too much load on the rear axle and getting too much overhang that very soon it doesn't make sense to use a Unimog anymore. So if you are happy to live with what can be fitted in a 4.5 or 4.9 meter body, then the Unimog is still an option. Yeah? And the available engine power also is not great, but it's okay. But you need to stay with that size on the Unimog, otherwise it doesn't make sense to use a Unimog. And of course you have to love the Unimog because the driver's cab is relatively small, it's relatively noisy, so your preferences must clearly be, I want very good off-road capability, rather I want very good comfort. If you want a longer body, more than 4.9 meters, if you want a comfortable ride, if you want more horsepower, then you have to go for a truck chassis. And the truck chassis, we mainly use MAN, while we also use Mercedes trucks, we use Volvo trucks, we would also use Scania or other brands. And that's why if it's a small vehicle, Unimog is okay, but for all the bigger vehicles, it's a truck chassis and mostly it's a MAN. It's I hope that answers your question. Okay. Okay. So one new question that just came in. Let me answer it. Hopefully, you have time to listen to my answer. How long will it take to load your batteries when there is hardly sun? So when you drive your engine stationary, will it take almost an hour or more for a full battery? Well, if you charge your batteries from the alternator with running the engine stationary, it will typically take 5 to 8 hours, definitely more than 1 hour. Looking at the typical size of battery pack and the typical size of alternators. I mean, there are big alternators, but you also have to fit them on the engine. And you have to have a belt that can provide the power which you need to run the to run that alternator. So 5 to 8 hours you would need to recharge your batteries, but running and then you have to run the engine at a higher RPM. So if you idle the engine, it will not provide full amps, so it will be noisy. In practical, nobody's hardly doing that. Yeah, that's my answer to that. I mean, you mainly use the alternator when you're driving, but not for idling. Yeah. Do you prefer to use larger solar panels like 325 watts with 65 volt open circuit voltage, or many smaller ones? Okay, let's let me answer this question as the last question for today. Well, we pick the panels according to the available space. If we have to use smaller panels to fill up the roof, we do that, and we combine them. But if there are if there is a huge roof and big panels just fit, we use big panels. Mostly we use 215 watt panels because they are 808 millimeters wide, and 3 of them just make almost the width of a typical body. And that gives us a very good efficiency of using the space. Of course, we either use panels with high open circuit voltage, or we combine other panels to get to that high voltage. What you should know, and I think Maiko knows, but maybe not everybody knows, the voltage that comes from the solar panel changes with the amount of sunlight that's going onto the panel. And what you should not do is, if you have a 12 volt battery system, to use a 12 volt solar panel, because the open circuit voltage of that panel will be 18 volt, but there is quite some time where the voltage that comes from that panel is below the voltage you need to charge your batteries. So even if you have only little light getting on the panel, there is still some energy coming out, but at a too low voltage level. Now, if you have a 12 volt system, you should at least combine 2 12 volt panels to a 24 volt system with an open circuit voltage of 36 point something volt to always stay above your nominal voltage of your system. And if you have a 24 volt system, you also need at least 36 volt, means 3 12 volt panels in a row, or 48 or 60 volt or 72. All you have to make sure is that your voltage doesn't go too high up, because then you are fighting with insulation problems, because it's not considered to be a low voltage system anymore. But never use a 12 volt panel for a 12 volt system and yeah, the open circuit voltage should be at least twice your nominal voltage. Another thing, a reason to use smaller panels, and also a reason not to run all the panels through one regulator, is that if you have a shadow on a part of the panels, yeah, this will stop a section of your solar panel at least. And the more panels are on that string, and the more panels are on that regulator, the more loss you have by shadow on the solar panels. So make sure, I mean, you cannot connect different types of solar panels to one MPPT regulator. So it always needs to be the same. Like when you have 9 panels of 12 volt 100 watt, you can put 3 in a row, and those 3 rows parallel, and you can run them all through one MPPT regulator. But if you have then on the other hand 2 or 3 12 volt 200 panels, 200 watt panels, you cannot connect them to the same system. That will be a mess. Okay, no, so getting the best space usage is driving our decision what size of panels we use, and we prefer to use more regulators rather than less to make the systems more independent. Yeah. Okay. I think that's enough for today, hopefully. I hope it was a little bit helpful. Yeah, hope to see you again next time. Next Monday, we will definitely talk about the loose equipment. We will also provide a small video. We will show you some of the stuff, explain why you should have it, what it's good for. And I think it will be quite interesting topic and a quite interesting life. And so ring the bell, subscribe the channel if you want to get information that when it happens. Yeah, enjoy the rest of the day. Stay safe. Thank you for listening, and see you next time. Thank you. Bye-bye.